2,955?
Yeah.
And how many million are we going to do that by?
5.
5 million. All right. Hey folks, welcome out there to Mathline Specialized Segments. You've got the right place, got the right time and everything. I'm Ernie Roberts. I'm your host for this afternoon's session of, as we said, Specialized Segments. You say, well, what's the big deal on Specialized Segments? Well, it's not one of those afternoons we're going to ask you to call in. However, you can still send us emails. You can still check with us on Facebook and share. Oh, in fact, we hope you will share these episodes, all right, that you have there. And also, you can check us out on YouTube and all those other things. Facebook, Twitter, we've already put all those things out there. However, this afternoon, it's time for you to sit back, relax. We're going to focus on a nice, in-depth topic and see where we can go, all right? So we've been working on special triangles. I have a feeling we might have a few more special triangles up our sleeves today. Let's see what we've got going today, guys. It's just what it is. And in fact, we're not going to do special triangles. We're going to mix them up. You say, Bernie, how are we going to mix up special triangles? Well, we've got 45, 45, 90s, which we haven't touched in a while, and 30, 60, 90s. We're going to go back and hit the 30, 60, 90s a little bit at the beginning, and then we're going to mix those 45, 45, 90-degree triangles back in the game. By the way, they are special right triangles. We call them special triangles because they have 90 degrees in both cases, all right? So let's see what we have going, what our first problem looks like for today. Crazy looking figure there. Looks like on the surface you see one big triangle, but then some of you said, I don't see the big triangle. I see two little triangles. There are 3 triangles in this picture. And we have 1 degree marking, and we are going to tell you this much. We have right triangles. We have right triangles. We have right triangles. I just said 3 times because there are 3 of them. So this little guy up here is a right triangle. This little guy down here is a right triangle. And don't forget, you get the whole big picture is one right triangle. Not only are they right triangles, notice we've got a 30-degree marker here. Let's see what's going to happen. In terms of the big game here, the big triangle, we got a big triangle, right? In terms of that, we have a 30 and we have a 90, which leaves us, you got it, 60 degrees right up there in the corner, upper corner, 60 degrees right up there. Now, what are we going to do down here? There's 2 angles here waiting to have some marks on them. Well, if this is 60 and this is 90, folks, we're going to put a 30 right in there. And over here, we're not really splitting the difference. We are going to have what's left over, which is 60 degrees. So looky, we've got not only one big 36, we've got 3 of them. We got 3 of them. 2 rather small ones, and then the big one that encompasses both those triangles glued together. That's impressive. And I'm going to tell you something, because they're all 30, 60, 90-degree triangles, they are similar. They're also similar. And you mean, what does that mean? It means same shape, but different sizes, but those sizes are going to be in proportion to each other. Now, we're not going to get that deep and all. We just want to find the missing links, and then you can probably go back and figure out, what's in proportion here, how the proportions are working and such. From the first to the second to the third triangle. Interesting problem here. Very interesting. Let's look at that interesting problem and see where we're going to go with it. First, let's see what's happening. Where do you start? Which triangle do you want to start with? I think there's a 6. By the way, that's the only segment I'm giving you. We're going to find the rest of them based on that 6 and based on the fact we have 30, 60, and 90-degree angles all over the place, running rampant in this figure. So let's see what to do first. Let's talk about the small one. Just kind of put your finger over it or ignore it. It won't go away. It's still going to be there. But let's play off the first one up here. This little guy is in the little triangle, the small triangle up here. This little guy is actually playing the side opposite the 30. You say, what does that mean, Ernie? That means it's going to be the smallest. It's going to be the smallest side of this 30, 60, 90-degree triangle. What do we need to do? Well, we need to remember some of the rules. That's going to be the first thing we're going to go with, because some of you are like, I haven't tuned in the last few weeks, Ernie. I don't know what the rules are. Let's put them up here. First of all, C is going to be our hypotenuse in the 30, 60, 90-degree triangle, all right? So it is equal to 2 times A. You say, where's A? A is going to be the side opposite the 30. It's the shortest side. It's the shorter of the 2 legs. C, our little c here, it looks like a big C, doesn't it? The C is going to be this length of the hypotenuse. So in other words, length from A to C is where we're going in this. Now, what's going to happen from here, we're going to put a 12 right there. because that's not going to change. It's going to change. We just doubled that. We just doubled that. Wonderful. You said, well, what do we do with this thing? What did we do that? It's that CD. It's actually an altitude from this point up to the hypotenuse of the big guy. But in our little 30, 60, 90 over there, it's going to be the B value. You said, what is B about? B is the middle length, and it's going to be worth A times that square root of 3, the magic moment, magic moment. Now, once we got that magic moment ready to go, all we got to do is figure out what A is. Well, we do. We know it. It's 6. So if we 6 times 2, that gave us 12. Halfway home in that triangle. And that tells me right here that this is going to be, I'm going to put it on the outside there, it's going to be 6 times the square root of 3. And don't try to make that anything but 6 times the square root of 3. We're going to leave it in radical form. If you wanted to figure out what it is on the calculator, it's not quite 12, but it's certainly larger than 6. And you can multiply it, but it's an irrational number, and you'll be rounding off the nearest 10th or 100th. We're just going to leave it in radical form and move on with it, because that's what we've got going here. It becomes a lot easier. Now, where are we going? Where are we going to go, you say? Well, I got 6 square roots of 3. That's pretty. But you know what? Look at the big triangle. Look at the big triangle. I now have a piece of it. Interestingly enough, the 12 is the hypotenuse of my smallest one, but it's going to become, wow, it becomes the smallest or the shortest leg in the big 30, 60, 90. See, what does that tell you? Well, that tells me right here that I've got a big 30, 60, 90. So there's 30, there's the 60, and it leads me down to CB. And that's going to become literally, looks like 12 times the square root of 3. And you say, well, Ernie, if we'd started with the 6 square roots of 3 opposite the 30, could we have gotten there also? We certainly could, because this thing is also playing C with these 6 square roots of 3. So we can double it right there and have 12 square roots of 3. So you can get it from the big triangle. You can get it from the medium-sized one. This little guy over here ain't going to help you much, all right? But the 6 roots of 3 definitely does help you, as does the big 12 there. Now, where do we go from here? I think all we need is one little piece. All we need is this one little piece right there. A couple of ways to get it. Since we were talking about going here and doubling, why don't we multiply 6 times the square root of 3? And why don't we just multiply another square root of 3 by it? Because that's what the formula says. If I've got an A, multiply by the square root of 3. And that will lead you to dB. You say, well, Ernie, the square root of 3 times the square root of 3, does that give you something special? It certainly does. It gives us a 3 without the square root anymore, because it's really like a square root of 9, and the square root of 9 comes out to be 3. So let's look at it this way. It's going to be 6 times 3, which gives us 18. So no matter what unit we had there, here we go, this is going to become 18. Now, some of you are probably thinking, if you add 6 and 18 together, you got it. What are you going to get? We're going to get 24. We could have also used that 12 to pick up 24 out here, because remember, we're doubling to get out to there. And that would leave us 18, because we've already used up 6. So take 24 minus your 6. Again, 24, the big long length, minus this little part we knew. That would give us that 18 also. So once you get rolling on a problem like this, there's more than one way to get out of it. Sometimes you have to get started in one certain way, but once you do that, there are other parts and pieces of this puzzle, because we're looking for 3 different symmetrical triangles to help us out. There's lots of different ways that we can come up with those final answers. By the way, if we were to find the missing length of each segment, those of you like to write things down and like to list things, how about it? We've got AC started off as being equal to 12. We picked up CB, we're looking big triangle right now, of course. 12 times the square root of 3, because think big. And then we can also get AB, which is the hypotenuse of that big 30, 60, 90 degree triangle, to be 24. Now let's take a look at the little individual pieces that are kind of inside the puzzle. We have DB or BD, however you want to look at it. That came out to be 18. And to finish it off, CD right up the middle there, going out toward that hypotenuse of the big guy, is equal to, what do you got? 6 times the square root of 3. Now those can be units of centimeters, meters, inches, what have you. But they're in that relationship, if you will. And notice, how do we get there? 2 sweet formulas. 2 sweet formulas that basically are all about where do you find it. C is the hypotenuse of whatever triangle you're talking about. If you'll keep that straight, that helps you a lot. Little c, we'll call it. And then we come along here and say, if we know the smallest piece, we can certainly find the middle piece. And by the way, you can back it up also. You could also divide by square root of 3 if you were given in such a way that you needed to work with that. But that's our first starter. Boy, you say, Ernie, you started us off with a pretty hard problem. Well, today is where we are. We're going to mix it all up, and we're going to show you how we can really get out of these problems, and they aren't that hard. They aren't that bad if you just look at it as being small pieces of a rather large puzzle. All right? Let's take a look at our next problem here. Problem says a rhombus has a 120-degree angle and a perimeter of 40. Let's talk about what that 40 is about. It could be feet, inches, whatever. It's a perimeter of 40. We're going to look for the lengths of both diagonals. You say, whoa, that's kind of crazy. It is. But let's first talk about what the perimeter of 40 tells me. Because remember, with a rhombus, all 4 sides that we've got here, all 4 of these sides are going to be, you got it, they're congruent. So we'll mark them as such. Put them little tick marks on them there. Here we go. That means we're going to split that perimeter of 40, 4, count them, 1, 2, 3, 4, ways, gives us 10 each. I like 10 because it's an easy number to work with. Very easy number. And we're not trying to make this difficult. All right, so it says find both diagonals. And the hint is you have a 120-degree angle. Now, folks, 120 degrees, that's obtuse. And if we look at our rhombus, we know it's a parallelogram, first of all. So we know this angle matches up to this angle, and these 2 measures have to be the same also. Now, I'm going to tell you, you can use your eyes and figure this one out. This is acute. This one's obtuse. We're looking at 120 degrees, which is obtuse. So let's draw a 120. I'm going to put it right out here. But that 120 degrees goes right in there, okay? It's a big angle. And you know what we're going to do? The reason I put that out there, we're going to split that angle right into by diagonal because that's what rhombus diagonals do. They're wonderful. And we can get the pen to mark. We'll have a great diagonal there. There we go. That's pretty good. So it splits. But you know what that means? That means we got a 60. We got a 60 here. Over here we have 60. We have 60 here. You know what that tells me? It already told me if I had 120 degrees for the big angle, it tells me 60 because those 2 angles have to add up to 180. And all 3 of these angles in that equilateral triangle add up to 180. Did I say equilateral? Why did I say it? Because all the angles are the same. That means all the sides are the same. Folks, we just have our first diagonal given to us literally on a silver platter. It's 10 units, whatever you want to use. If you have inches, you have feet, whatever you got for that. There we go. Well, that was easy. Hey, you're 50% there, right? Now, let's see what we're going to do with this other diagonal. We're going to send it right down the center and bisect this other angle. And some of you go, I know it's going to happen when you bisect to 60. You're going to get 30. Exactly. And so I'm going to try to keep this as easy as I can to look at. We're going to put the 30 down here. By the way, the 30 is everywhere up here. These 2 little guys, and this one over here is 30. But we're interested in figuring out what is going on from here to here. We've already got the horizontal diagonal finished. It's good. It's good. All right. We want to go for the vertical. We want to go for that vertical one. All right. Hang with me. I see 30, 60, 90s. You got it. So let's play something out of this. I'm going to go back to that. Let's go back to the relationships. All right. Remember the formula. C is equal to 2 times A, which we have pretty much going on here, I guess. You say, well, I don't see a 5 anywhere. We'll put 1 in there in just a second. And then, of course, once we figure out what A is, how about it? We're going to multiply it times the square root of 3, and we'll have the value of B. Now, by the way, B is going to be this little guy right here. And, oh, did I mention, or did you all mention? Do you remember? We get 90-degree angles back here because rhombus diagonals are perpendicular. My goodness, it's like we're having a whole lesson about what to do with rhombus situations, rhombus rules, rhombus regulations, whatever you call it, R&R. Then we also have our 30, 60, 90s on top of that. So this is a good little review problem, great little review problem. Let's see. We have and you said 30, 60, 90. I sure did because there's the 90, there's the 30, there's the 60. All together, right triangle, 30, 60, 90. So we're playing C as 10. Why? Because, well, in that 30, 60, 90, my friends, it's a hypotenuse. It's a hypotenuse. So that's going to give me a 5 right back here. Right back here because what do you know? Opposite of 30 is 1/2. Now, remember, I went ahead and told you that we've used that part of the formula. Now it's time to play this one out. If A is opposite the 30, which it is, and it equals to 5, which it does, multiply it by the square root of 3, you will have, you're going to have 5 times the square root of 3. Well, it's getting a messy looking figure, and too bad I just couldn't blow up that rhombus to be like 20 feet tall or something, but you get the idea. You get the idea. Right down there is 5 square roots of 3. And some of you go like, I think I made mine at home a little bit smaller than yours. Uh-oh. You know, it does help to give us some room to breathe. Now, when we get inside here, speaking of room to breathe, we're looking for a second diagonal because it's all that fun, all that stuff's going on here. It gets a little distracting, right? Now, let's see where we're going to go with this thing, this second diagonal, we want to call it. You got half of it right there with 5 times the square root of 3. Double it. Just simply move. You say, well, how do I know to double it, Ernie? Because what do you know? Yep. Diagonals of a parallelogram, they'll bisect each other. My goodness sakes alive. So that means we got another 5 roots of 3 there. I'm looking at 5 plus 5, which gives us 10. And we're going to have 10 times the square root of 3. So there are your 2 diagonals based on one fact. Actually, 2 facts. You had 30, 60, 90s. And you knew your rhombus had a perimeter of 40. That led us to the 10s. 10 led us to 5, and 5 led us to 5 square roots of 3. Double those pieces, you'd have 10 and 10 square roots of 3. It's another way of looking at it. I drew it from the equilateral triangle, but you could have gone ahead and slam bam, right there you go. Put the 2 diagonals in there, go to the 30, 60, 90s, rock on, and it'll work. It'll work. So there you go. Whew. Specialized segments. Did I tell you it was going to be in depth today? It is in depth, isn't it? But that's what's good for you. It's how you learn. It's how you grow a little bit. Let's look at a problem that was rather similar to the first one we had. Let's take one more look at it, 30, 60, 90. I've moved our little 6 to another point. Now this is a 30, 60, 90. Let's see if we can get that. Here we go. That looks better. We've got a 60 down here, and my friends, here we go. Over here we have 30 degrees. Now remember, I put right angles on those. That's how we know that we have a big 30, 60, 90. And that's how we also are going to figure out we have little 30, 60, 90s. Because here's a 60, and right over there we got a 30, barely shines through. Hopefully on your TV sets it looks a little bit better than mine. Now, where do we go? One number. Now, this time, my friends, I moved the 6 around a little bit. Yeah, he did that. He sure did. So let's work in the dark blue triangle. Let's see what's going to happen here. We're going to take this part is little a. Remember the rules. A is half of C, or C equals 2 times A, however you want to look at that. But in this case, I basically had to double something to get 6. Or I have to half 6 to get back to that something. That something is going to be a 3. That was easy. The rule says now we take that little a part and multiply by what? You got it, the square root of 3. Formulas do not change. They do not change. Just because I didn't give them to you again, they're still what they were on the last 2 problems. So we have 3 times our square root of 3. Well, that's exciting. We just found 2 of the missing segments. We still have a few more to go. Now, this time, let's play off the light blue triangle. Why not? And then we can figure out by adding what we have results there together at the end. I already think I know where it's going to be. And some of you say, I already figured it out too, Ernie. I looked at the big triangle and it was easy. I'm hoping it is. Let's look at this little light blue triangle over here to the left side of your figure. You've got opposite the 30, which means it's a shorter leg. How do we go from that shorter leg to the hypotenuse? We multiply it by 2. We double. That's going to give me 6 times the square root of 3. Now, here's the little trick. How do we get to the b part? Well, remember what we said? B equals what? Little a times that square root of 3. Well, we picked a to have 3 times the square root of 3. Now, don't get excited. But you got to put another square root of 3 in the pocket. You can't say, oh, well, it was in the formula, so I guess he already used it. No, he didn't. This was a, that's an extra square root of 3 we got to multiply by. So if you really get right down to it, that's like saying the 3 times the square root of 9. But we all know when we take the square root of 3 times the square root of 3, you get 3 without the radical. Because at this point, if you're watching this show, that's probably where you're going. So, whoo, I just jumped it, didn't I? 3 times 3, that's where we get 9. This equal to 3. So 3 times 3, go there and go there. Right there to the sign. Okay? And, oh, where did that go? That's BD. You're still wondering, well, what's AB? I think everybody can figure that one out by now. Take the 3, add the 9 to it, and you, my friends, have a 12. Oh, look at the big triangle. 6 square roots of 3, and 12. 30, 60, 90. It works on all levels there. So we got all the segments? I believe so. Once we found that long one, we have all our 5 missing pieces. And that's your story there. Very straightforward. Now I said we're going to mix them up. You said we aren't mixed up yet? Now let's take a look at one with a 45, 45, 90 and 30, 60, 90 glued together literally. So here we go. We've got those 30, 60, 90 rules down very well. Let's go ahead and put it in. By the way, how do I know it's a 30, 60, 90? Well, I see the 90, I see the 30, so here is the 60. Now, don't get everybody going crazy yet here. This is not a 90-degree angle at the top of your figure. You can't assume that it might look that way. It's a little bit off. This is going to be a 45 here because we have a 45, 45, 90-degree right triangle. These come together to actually make 105 degrees. So we can't just jump anywhere. We've got to come back to using our little rules here. We've got a hypotenuse of C, and we're going to work here to here, and then we're going to bounce over here and have fun with the 45, 45, 90. Got to remember those rules also, don't we? So let's go back to those quick moments here. 12's the hypotenuse. That means this little guy right here, he's half, opposite the 30. There's the 30, go opposite the 30. Does everybody understand what that means? Y'all got that? Opposite of 30 means go out across the other side of the figure and bang, there's your segment. That's the side opposite the 30. That's the 6. That's our 6. What goes on down here, you say? Well, Ernie, it's not A, it's going to be B. We'll call it B right there in terms of the 30, 69. By the way, this was our little A going. Over here, we're going to have, oh goodness, just like we did before, that 6 times the square root of 3. And by the way, don't try to make that square root of 18. Doesn't work that way. All right, it's just 6 times the square root of 3. You're stuck with it. It's kind of like a 6x. You're stuck with it unless you want to go and run it on a calculator and figure out what that is irrationally and get a crazy number and then round it off. That's fine, but we'll just leave it like that. Now over here on the other side, oh, different rules. They don't follow that halving business. Some of you are going, oh, that means that segment over there is 12, right? No, it does not. It does not. However, these two segments are congruent because it's a 45, 45, 90. I'll put a couple of ticks on those because those are congruent, my friends, which means these two sides are. So I've got this little length going at 6. You say, well, Ernie, what's that make the whole length down there? Why don't we go after it? It's going to be 6 plus 6 times the square root of 3. And folks, caution, those are not like radicals. I mean, there's not even a radical on that 6. Just because you have 2 6s does not give you 12. This gives you 6 plus 6 square roots of 3, done. Now, quick rule. What goes on in this side here? How about it? C equals A times the square root of 2. Yippee. And you know what that gives? That gives us 6 square roots of 2. Some of you thought that was going to be 12, but look, that's not the same length as 12. Okay? It's not the same length as 12. So you don't want to put a 12 there. And besides, if you had a 6, 6, and a 12, the triangle would collapse completely. Yes, can't work. Triangle inequality says no. So speaking of no, let's see if we can do one real quickly here. Let's bump this along, all right? We are back to the same figure, but I moved the 12. Oh, you moved the 12, Ernie. How about that? So there we go, 60 degrees there. We know the game here. This is 45. What we got to do is figure out what's going on back to here. We've got to divide by that square root of 3. So let's do it real quick. 12 divided by the square root of 3. Got to lose it. Got to lose that square root of 3 in the denominator. Can't keep it. So this gives us 12 times the square root of 3 over 3. Now some of you say, what did you just do? I basically said that if I'm looking for A is equal to B divided by the square root of 3. Why did I have to go here? Because I'm opposite the 60. So put it, by the way, that's going to give us 4 times the square root of 3, whatever units you're using. It's right here. Double it. Double that number to get to your hypotenuse on the 30, 60, 90 triangle side. Now remember, we're going to go over here in just a minute. All right, double it. I think we're going to see 8. And put a square root of 3 attached to it. You say, whoa, it's a lot of square roots of 3. Well, there got to be 2 of them or 1 of them in a 30, 60, 90. You can't just have nice, sweet integers. Doesn't work that way. So we got a 12, we got 4 square roots of 3, and there we go. Now over here, remember I said isosceles. Isosceles, everybody in isosceles? Yeah, we'll mark it with a tick. And that means this little guy is also 4 times the square root of 3. Crazy looking long segment there, isn't it? Let's do it. We got to multiply that by square root of 2. So take your 4 square roots of 3, multiply by the square root of 2. Isn't that hard, folks? It's just radicals. And you're going to multiply it 3 times the 2 because they're under the radical. Keep the 4 alone. And I now have 4 times the square root of 6. And dear friends, there is your hypotenuse. And there's kind of a crazy problem, all right? And what did we say about the last one? 12 plus 4 roots of 3, or 12 square, let's try that again. 12 plus 4 square roots of 3, that would be your last long segment. Okay, and you've had it today. Whew, we're all mixed up. I hope it didn't mix you up. Hope you've enjoyed the show today. We'll be back again live next week, all for good stuff and another specialized segment too.